All right, we're on to our next section here in Earth Science, which is volcanoes. So we're going to study the nature of volcanic eruptions and basically how volcanoes start. So start by taking 5 notes, just notes, no complete sentences are necessary here, just notes on the video that you see right here. Here we go.
You guys, we have discovered one of the largest volcanoes in the solar system, and it's right under our feet. Well, I mean, sort of. It's like over there. Hey everybody, I'm Trace. Thanks for tuning in to D News today. If you followed science news at all last week, you probably heard that the second largest volcano in the whole solar system was discovered under our own Pacific Ocean. And if you're a curious bunch, then you probably wondered, what is the largest volcano in the solar system? We've got that and some other crazy volcanic stuff. Here on Earth, we measure mountains by their height above sea level. But in space, we rarely find seas, let alone know their average level. So extraterrestrial mountains are measured root to peak. Regardless of how you measure it, though, the largest volcano or mountain we know to exist is Olympus Mons on Mars. This mountain is so large that if you plopped it here on Earth, it would cover the entire state of Arizona, dwarf Mount Everest, because it's almost 3 times its height, and standing at its peak, you would be a quarter of the way to space. It's 15 miles high, guys. It's got so large because Mars plate tectonics don't work like ours. Here on Earth, the crust shifts, moving volcanoes off hotspots and magma pipes where that molten lava seeps through. So they're only so tall before they're shifted away. Think of the islands of Hawaii, for example. On Mars, plate tectonics are slow, even by geologic standards. So Mons sat on a magma pipe and kept growing and growing and growing. I use the past tense because astrophysicists are pretty sure Mars's core is cold and all the magma has solidified. The largest volcano on planet Earth is now this new one, 4 miles under the Pacific Ocean, 1,000 miles off of the coast of Japan, Tamu Massif. It's not very tall, but it covers the land area of New Mexico, or the entire British Isles. It's nearly the size of Olympus Mons, so it's definitely in that class. And because of this discovery, scientists have to reevaluate how these giant volcanoes form, as it was previously thought Earth wasn't able to push enough magma around to build something this large. Tamu Massif formed 130 to 145 million years ago out of a bunch of different lava flows and magma pipes, it seems, and it's extinct, so it's not going to erupt. You don't have to worry about that. The most volcanically active place in existence isn't on Mars or on Earth or even on one of the 8 planets, actually. It's on one of Jupiter's moons, Io. Io is the 5th closest to Jupiter, and its 3rd largest moon. It's roughly the size of our own moon. The surface would probably be the closest thing to hell that you could get outside of fiction. Io is extremely volcanically active, with plumes of volcanic activity shooting 190 miles into the atmosphere. Its orbit with Jupiter crosses 2 other moons, so gravity causes its surface to bulge in 300-foot waves, releasing magma floodplains, which is probably molten sulfur, which is why it gets its yellow color and why Io would probably be real stinky. Aside from all of its volcanoes, its orbit also crosses Jupiter's magnetic field, creating 400,000 volts and 3 million amps of electricity across its surface. It's released as lightning in Jupiter's upper atmosphere. That makes Mons and Massif seem pretty tame, huh? You guys, this is just the beginning. We have only just scratched the surface. Volcanoes are fantastic pressure release valves, and who knows how many there are out there to discover, not just here on Earth, but in the whole universe. They are definitely one of my favorite natural disasters. They're powerful, they're crazy large. Do you have a favorite? Share it with us, and we'll see you next time on D News.
Okay, pretty energetic dude there, but some really cool stuff he had to say about volcanoes not only here on Earth, but also on other planets and moons throughout our solar system. So let's get into some volcanoes here on Earth. First of all, there are 2 ways that volcanoes erupt. They erupt either quietly or violently. As you can see from the 2 videos here to the right, the top one with the Coke can is the one with the lava that erupts very quietly. As you can see, this lava is moving very slowly, and if I turn the volume up on this, you probably wouldn't hear very much because there's not a whole lot of explosions that go with a quiet volcano. However, on the bottom, if you'll notice, that's a violent volcano. That one has lava and the ash cloud, as you can see, rising up very quickly, very explosively. So it's called a violent volcano because of how it erupts. So on top, very quiet, not much sound. That's why they call it quiet, but more importantly, the lava moves very slowly. And on the bottom, very violent eruption from a different type of lava and a different type of volcano that occurs. As you can see, the lava right here is moving pretty quickly. And this is caused by what is called viscosity, and that's basically the resistance of a fluid to flow. So the fluid is resisting flow. On the top, as you can tell, that Coke can kind of just disintegrates into the lava because it moves so slowly. On the bottom, those are literally rivers of lava, huge monster rivers of lava that are moving at a pretty rapid rate because they have what's called a low viscosity. So they don't resist flow much. They kind of just get going really fast. So violence erupt either quietly or violently. It depends on something called viscosity. So what exactly is viscosity? Well, viscosity is the ability of a substance to resist flow. So just like if you were to resist anything, like say resist talking or resist someone trying to ask for your number or something, you would not want it to happen, or you would try to work against that. Viscosity is the same way. It's when a substance resists flow. In other words, it moves very slowly. At the top, that's actually there's two speeds there. There's actual speed and half speed, but that's caramel, and that's also melted chocolate. And you can tell that moves pretty slowly. They kind of throw it against the wall, and it moves very slowly. But on the bottom, that's just plain old water, and water has what's called a low viscosity, so it moves very quickly. So if a substance has a high viscosity, like caramel or chocolate or syrup or oil or tree sap, it moves very slowly. If it has a low viscosity, it moves very quickly, like water or some of your other liquids that might not be quite as thick. So high viscosity moves slow, low viscosity moves very quickly. And so what does that have to do with volcanoes? Well, a high viscosity lava is like this video on the bottom, where the lava resists flow. In other words, it doesn't flow very fast. It's very thick lava, it's not explosive, and it just moves really slowly. Since it moves slowly, these are the volcanoes that have the quiet eruptions. Okay, they're not big, they're not explosive, they don't kill a lot of people because, well, the lava moves really slowly. An example of this would be the clip below, which is actually of the Hawaiian Islands. If you've ever visited Hawaii, or maybe someday are going to visit Hawaii, you're standing on a volcano. The reason why you can stand on a volcano is because that's a very quiet erupting volcano. It's very slow. Sometimes the lava only moves like a foot or two per day, so it's easy to get away from. Is it hot? Yes. Could it be dangerous? Yes, but it moves so slow, it doesn't really cause a lot of damage. So basically what happens is the islands just continue to grow as that very slow-moving lava meets the ocean, and you see it causing steam there, and it cools and makes the islands bigger. So the Hawaiian Islands are actually getting bigger every day because of this very quiet, slow-moving eruption. On the other hand, the fun ones are the ones that have the low viscosity lava, and these are the ones that are very low resistance to flow. So in other words, they flow very quickly. In the video below, you actually see several very explosive eruptions from low viscous liquid volcanoes, and these are the ones that are very fast moving and they're very explosive. These are also called violent eruptions. These are the ones they make movies about, ones that are dangerous, and unfortunately the ones that kill people and destroy homes and things like that. These are the big boys. The reason why they are so big and explosive is because they have a low viscosity lava. So if you were thinking about the caramel and the chocolate, those are high viscosity liquids. They move very slowly. This would be like the water. Now, of course, it's not water. It's actually lava, so it's moving very quickly, as you can see. And these are the ones that cause all the problems that are very dangerous. An example of this we'll talk about, probably the biggest eruption here in the United States, at least since we've kept track of volcanoes as scientists, was the Mount St. Helens explosion back in the early 80s in the state of Washington. We'll watch some videos on this. This is a pretty explosive eruption. As a matter of fact, some of the erupted materials actually came here to the Kansas City area, so carried through the air several thousand miles and came here, and we'll discuss more of that. But the reason why those particles were thrown so far into the air is they had a low resistance to flow, so the lava was very easy to move. It was very thin. It was very explosive and violent and caused a lot of damage. So low viscosity is very violent and explosive. And here's what happens. If you ever drink a soda, or I like to say pop, there's gases in there. what makes you burp or makes your stomach feel kind of weird, or the fizz you hear when you open up the can. Those are very similar to magma that's inside of a volcano. There's gases that are trapped inside of the volcano just like there is in a can, just like what these guys are exploding here. And the volcano will depend on how easily or uneasily those gases escape. So if the gas escapes the volcano very easily, that's a quiet eruption. That's like the Hawaiian volcanoes and those that really aren't very dangerous. Just, the volcano's kind of always flowing because the gases are always escaping. But there's not a lot of damage. Is the lava hot? Yes, but because those gases can escape easily, it's like when you open up a pop, the top of a pop, really slowly, you let the gases escape easily. So it's a very quiet eruption. It doesn't make much sound with your can of pop. It doesn't make much sound or cause much of an eruption when it happens in a volcano. Opposite thing happens if you've ever shaken up a pop really hard and you open up the top. It has a violent eruption because all those gases are kind of stirred up and they're trapped inside that can or that bottle and they want to escape. Same thing happens with an eruption of a violent type. The gases inside, caused by the magma because they can't escape, build up and get stronger and stronger, and eventually they just simply blow the side of the volcano or maybe the top of the volcano apart. And when they do, it's a very violent eruption because those gases are trapped inside and they have nowhere to go, so they just build up strength and eventually explode. So the type of eruption depends on whether the gases inside the volcano can escape easily or not. If they can escape easily, very quiet eruption, no problems. If they can't and they become trapped inside and have nowhere to go, they slowly build up and eventually you have a very violent eruption. Okay, so there's three types of volcanoes based on their types of eruptions. The first one's called a shield, the second one's called a cinder cone, and the third one's called a composite cone. And some scientists actually call them stratovolcanoes. So if you hear composite or stratovolcano, they're actually the same thing. Shield volcano looks like a shield, literally like a warrior shield is laid down on the earth. Very long slopes. They're very big volcanoes, but they're not really as so much tall as they are long. As you can see from this picture here, it's a very long volcano, one that really stretches out across the horizon. Next one is a cinder cone. The reason why they call it a cinder cone is, as you can see, it is a cone shape, but it also erupts what are called cinders. We'll talk more about that shortly. Finally, the fun ones that everybody likes to talk about, and once again they make movies and tell all these crazy stories about, are the composite cone volcanoes. And the reason why these are so impressive is, first of all, they're really tall. As you can see here, these have snow on them, which tells you they're really tall. But also, these are the ones that the gases do not escape very easily. They're trapped inside, sometimes for thousands of years, and eventually those gases want to get out, and they explode and cause violent eruptions. So the three types of volcanoes: shield, cinder cone, and composite cone, also called a stratovolcano. So the shield, like I said, looks like a shield volcano. So you can see in the picture at the top, it's a long volcano. Not so much tall. They are tall, but their size lies within how long they are. It's a dome structure, and like I said before, it looks like a warrior shield. It looks like a warrior literally laid his shield down on the earth and made this dome structure. Many of them, as you can see from the video down here in the bottom, this is actually an island that's forming out in the middle of the ocean. So land that comes up through the surface of the ocean and eventually creates an island. Just like the Hawaiian Islands, or many of the islands throughout the world, are created from volcanoes that start at the bottom of the ocean floor and eventually reach the surface of the ocean. This is the formation of one of those such islands here. The reason why shield volcanoes grow to be so large is they have very slow moving lava. So you can see down here in the corner, once again, this is actually a picture of Hawaii. You can take tours and go stand right next to this lava because it's not very explosive. You don't see this big ash cloud, a lot of smoke, a lot of steam. You simply see a lava that kind of just flows and eventually reaches the ocean and makes that shield volcano larger. So a shield volcano with a dome structure, much more length instead of height. Many of them start on the ocean floor as very slow-moving lava. And an example of these would be like the picture down here to the right, which is the Hawaiian Islands. The next one up the chain is called a cinder cone. And the cinder cone is also very steep, and it has a cone shape. That's why they call it a cinder cone. And what is unique about cinder cones is they actually erupt fragments. They're called cinders. not really much lava. That's why this volcano kind of has this ugly brownish, grayish, blackish type color, because they erupt cinders. They're called cinders. It's basically like if you grill and you have charcoal ash left behind, or maybe if someone unfortunately smokes in your family, there might be some ashes left behind in an ashtray. It's very similar to that, except of course it doesn't come from a grill or from cigarettes or other types of things you smoke. Actually, it comes from the inside the earth, and these are fragments or small pieces of rock, and not much lava. And that's why you don't see a lot of red in this picture. It's mainly like a grayish brown, black type color. Cinder cones erupt cinders, and that's why they're called, well, cinder cones. And our final type is the one that everybody loves, and it's called the composite cone. As I mentioned before, scientists also call these stratovolcanoes. They call them stratovolcanoes because strato means high or tall, and these volcanoes are exactly that. They're very tall, very large, and very, very explosive. These are the ones that you hear about on the news all the time, the ones that destroy um, a lot of land and a lot of areas when they erupt. The reason why is they have what we talked about before, the violent, large, explosive eruptions. These are the crazy ones. These are the ones with the big ash clouds, a lot of lava, a lot of steam, a lot of movement of land. These are the ones that are really exciting. An example of this is Mount Fuji in Japan. There's actually many of these throughout the world, and you're going to be doing a project over one of these composite cone volcanoes very shortly, but an example of this will be Mount Fuji in Japan. We'll talk more about Mount Fuji soon, but what's unique about Mount Fuji is it's a composite cone volcano, so it's very large, very violent, so it actually looked like this when it erupts. And there are a lot of people that just kind of live right on the mountain. There's actually a ski resort on the side of this volcano, and someday, unfortunately, it's going to look like this, and a lot of people are going to die, but they really don't care, because Mount Fuji right now is what's called a dormant volcano, but someday it will awaken again, and it will explode just like this, and there's going to be, unfortunately, probably a lot of people in Japan lose their lives. Last slide here. Some other volcanic features. Let me go back to that, I'm sorry. Other volcanic features that you will need to know for this section. The first one is a caldera, and that's basically just a large hole or large depression in a volcano. The caldera, as you can see here, this is in Yellowstone Park, which is out in the western part of the United States. Caldera is just this big hole right here. And the reason why calderas form is this volcano at one time erupted. It was a very large explosion, very large eruption. Someday this will happen again. And unfortunately, Yellowstone is going to have a lot of problems. But whenever a volcano erupts, part of the land is simply blown away. It leaves a large depression, which is called a caldera. So it's basically just that sinkhole, that area that's missing right there in the volcano. The other part is what's called the lava neck, and that's the middle part right here. Just like the neck on your body, it's kind of the tube that leads from the magma chamber down underneath in the earth, and it leads to the surface basically. So it's kind of a connector, just like your neck is, say, with the inside of your body and your mouth, that type of thing. It's basically just a large tube that connects magma to the surface of the earth. And off of that, this doesn't show it all that well, but are what are called lava pipes, and these are just smaller lava tubes kind of to the side that run off the lava neck. Sometimes you'll see them break off, kind of like your arms, your legs would be off the center of your body, and they break to the surface, and they'll allow some of those dissolved gases to escape with some of the non-violent eruptions, but unfortunately with the ones that are really big and violent, they don't have as many lava pipes, so that gas can't escape, and the eruptions are so much bigger. So caldera is the large depression, basically a hole in the volcano. Lava neck is this very large part in the middle, just like your neck, which kind of connects the magma chamber to the surface. And finally, the things on the side are what are called lava pipes, and they're just like pipes in your house or maybe your arms or your leg. They're just smaller tubes that kind of connect to the main part of the volcano and run off and connect to the surface. So that's volcanoes. Hopefully you've taken good notes. Show me these notes so you can get your points and keep them around so you can use them for future assignments and projects. See ya.